So this video is meant to summarize the results of your Ohm Sweet Ohm lab that you've just completed, and I'm going to try to hit what I call the highlights, okay? And so first off, this is a review, so this shouldn't be a big surprise to you, but these are the quantities that we measured, that we've seen measured in the circuits that we've looked at. And I'm just going to complete this, and just this is a review. So current is the variable of that is I. Okay, and the unit is the amp, and amp has the abbreviation A. Okay, voltage, the potential difference is V. These are basically synonymous, potential difference in voltage, and the unit are volts, and it's abbreviated V. And the last is resistance. Okay, and resistance is R, and it's measured in ohms. Okay, and ohms, abbreviation for ohms is omega. Okay, and again, I'm just going to remind you what Ohm's law looks like. Ohm's law is V equals I times R. The voltage of a circuit equals the current in a circuit times the resistivity of a circuit. And I just remember V equals IR. Okay, it's the easiest way to remember it for me. Okay, so if I draw circuits, here are the symbols I'm going to be using. For a wire, which is a conductor, I'm going to just use a line. A bulb, which is a resistor. There are two ways to draw that. One is kind of making a heart on the wire and then putting like a globe on it. Another way is to make a sawtooth resistor. This is a resistor symbol. And then put a globe on that. Okay. A resistor is just the sawtooth symbol without the globe. So it's this thing here, like that. And then a battery, the power source, the device that basically provides the voltage or the potential difference. Okay, this is the wire with a big bar, which is the positive side. And here's a little bar, which is the negative side. Okay, so those are the symbols. This is all review. Okay, so let's go to the lab itself and answer some questions about it. And I'm doing this because I want to make sure that you have a good understanding of this, and you kind of get how this works. Okay, so there's some questions at the bottom of this page, and I'm just going to kind of go through those, and I'm going to demonstrate them with this quick circuit I made using the circuit construction kit from PHET. And you notice that it's a really nice little circuit. I'll explain what's on it right now. There's a 9-volt battery, which is kind of a standard battery size. There's a 10 ohm resistor, the bulb. So the bulb is a resistor, and you can see the resistance of that. It's 10 ohms. The switch is on, so the circuit is closed, and there is current traveling. And the current are the red arrows. And you can see they're leaving the positive side of the battery, going through the circuit, through the bulb, and then coming back to the negative side of the battery, okay? There are 2 meters that I have available. One is the ammeter, which is built into, it's in the loop or on the loop. You could say that, okay? And you can see where it's located here, okay? You can see that it's located right in this area here, okay? So it's either, you can say that's either in the loop or on the loop. You can see the ammeter is measuring the current, 0.9 amps. Okay. Okay. And then I've got a voltmeter here. Now I haven't attached it to anything yet, but I will in a minute. I've got a voltmeter here, and I always put the red one on the upstream side and the black one on the downstream side. Okay, that's what I tend to do, right? So I get the voltage measured. Okay, so we'll show you that in a second. Okay. Okay. So let's answer some questions. So number one, it says, what happens when so I'm going to write down at the bottom Ohm's law. V equals IR. Okay? Okay? And it says, so number one, it says, well, what happens when you increase the voltage supplied to a circuit with one bulb? Okay, so let's look at that. So what we want to see is we want to increase the voltage and we want to see what happens to the bulb. Okay? So let's take a look at that. Okay? So I'm going to increase the voltage. Here's the voltage now, it's 9 volts. I'm just going to increase that to like, oh, I don't know, let's increase it to like something pretty big, like 30 volts, okay? Okay, you see the bulb brightens a lot there. Now I've got a 30 volt bulb, I've got 3 amps of current going through the circuit, and I've got a really bright bulb. You notice the resistivity of the bulb didn't really change, okay? So the answer to this question is the bulb is going to brighten. Okay, so what happens when I decrease the voltage? So I'm going to go ahead and I'm going to put it back down to 9 volts again. Okay, and you can see it's a lot dimmer now, right? So in this case, the bulb dims. Okay, okay, so it asks the question, is the current going into the bulb equal to the current coming out of the bulb? And let's take a look at that. Okay, so now I've got an ammeter here. This is the current going into the bulb. It comes out of the battery, goes up here, goes into the bulb. Now I'm going to add a second ammeter right here. And we're going to test this. Notice I can put another ammeter in this. You notice that, which is kind of nice. So we can actually see what happens here. So it asks the question, is the current going into the bulb the same as the current going out of the bulb? And the answer is yes. Okay, this is a series circuit. It has one current path. There is one path for the current to travel. So since there's one current path, the current is going to be equal for this over this entire path. Okay, so the answer to this is yes. Current in a series circuit has one path. Therefore, it's equal. Only one path. Only one path. So the current in the series circuit is always the same, going in and out. Okay? Now, then it asks you a question here. It says, can you think of a situation where the current going out of the battery would not equal the current going through the bulb? Well, yeah, I can. And it would be it would be if instead of a series circuit, I had a parallel circuit. Okay? And in that parallel circuit, I would have a bulb on each branch of the circuit. Okay? Okay. Now the next question, it says, is the voltage provided by the power source equal to the voltage used by the bulb? Well, let's find out. So the voltage produced by the power source is 9 volts. Okay? So what I'm going to do is I'm going to put this thing on one lead to the bulb, and I'm going to put the red one on the upstream end of the bulb. And you notice the bulb. So notice the battery is 9 volts. Notice the voltage drop across the bulb is 9 volts. You notice that from the top to the bottom, okay? You notice that? It's 9 volts. So the answer is the voltage provided by the power source equal to the voltage used by the bulb? The answer is yes, because there's only one resistor, one R on this circuit, okay? So all the voltage created by the battery all the voltage drop, all the potential difference is basically what I say is it's used by that one bulb. Okay? Now, if there was lost energy, where did it go? Right? Well, there is lost energy here, and the lost energy is heat and light from the bulb. Okay? Basically, it takes energy from the wire and it converts it to heat and light at the bulb. Okay? It's a resistor. Okay? Okay? So then it says, number 7, it says, can you think of a situation where the voltage provided by the power source would not equal the voltage used by the bulb? Okay? And the answer to that, yes, if there was more than one bulb. Yes, more than one bulb. More than one resistor. Okay? More than one. Okay? So what's a closed circuit? Well, a closed circuit has no breaks, no breaks. Current can flow. Okay? Current can flow. And I'm going to show you what a short circuit is in a minute, okay? I will come back to that. But I'll give you the definition. A short circuit, okay, a short circuit, this is a closed circuit. A short, I'm just going to write short here. A short is a circuit with little or no resistance. Okay? And then the electrical load. What is the electrical load? Well, the electrical load is the appliance. Okay? The load is the resistor, bulb, or appliance on the circuit. Okay? What's the terminal? Well, a terminal, terminal are the battery attachments to the circuit, and the battery has a positive and negative electrical contact. On the battery. Okay? Okay, let's go back to our FET sim and I'll show you a couple things. One, so first off, this is a closed circuit. Current is flowing. It's a nice, no breaks. Okay, it's not a short. There is a resistor on this current on the circuit, and it's 10 ohms. Okay, so this is not a short circuit. The load on this circuit is the bulb. That's the device or the appliance. Okay, the two terminals of the battery, one is here and one is here. This is the positive one, this is the negative one. Okay, now what's a short? Well, a short is where I have no resistance. So what I'm going to do is I'm going to detach this bulb and I'm going to have this circuit. And you notice what happens. Notice something here. When I take out the resistor, I have heat, and notice the current that's generated, 4,854 amps. So tremendously strong current here, okay? Because I have no resistance for this 9-volt battery, okay? So a lot of current, okay? And that's related, and so I get a fire here because I get heat and friction, okay? So this is a short. Here is a short circuit. Here is a circuit with little or no resistance, no resistor. So therefore, you have extremely high current values. Okay. Okay. So this is a short circuit.